Ever watch a coder be able to solve and create complex solutions out of thin air? It's not magic, it's a mindset. Let's dive into the video and learn different techniques to make you think like a programmer. Starting with step one, which is breaking down the problem, also known as decomposition. So whenever faced with a complex problem, being able to identify this one specific complex problem into multiple smaller problems that you are able to find solutions for or be able to create is essential to being able to solve the large complex problem. In software engineering, especially the agile methodology, the large complex problem is known as an epic, while the smaller problems might be tickets that can be accomplished within a sprint or a 2-week period of time. So let's think of a large application, like a social media application, whether that's Facebook, Twitter, Google, any of those applications. When looking at it, it looks like that is a large, complex solution to an application. And it is true, that is a complex platform at the end of the day. But you need to be able to break it down into smaller pieces. So we can think of Facebook, and then let's think of Facebook messaging. Well, Facebook messaging is one component of the entire Facebook application. So if we look at the Facebook messaging portion of the application, we can identify that that might be an entire feature, but let's break it down even further. We can say that messaging is complex in itself, but really what we need to do is have two individuals be able to message each other. So we can start breaking it down even smaller. We need to create the bubble of the user. We need to create the bubble of the person responding. We need to be able to type in input. Once you break down the complex problem into minor, smaller problems, you can start putting together the pieces of the puzzle which will create that complex solution. And that brings to step number 2, which is understanding the problem completely. Before even attempting to try and find a solution to the problem, one must be able to identify what the problem even is that's trying to be solved. And that's where the programmer mindset really starts coming into play. Let's say you're working on an application that a user is using and they're like, oh no, this thing's not working how it's expected to be working. Is it really not working as the user is expecting to be working, or is there different ways that we can solve this problem to benefit everybody, the coder, the user, and the entire application? When asking questions about the problem, make sure you're really asking every question possible so you can be able to digest the information of what the user is experiencing so you can solve it to the best of your ability, or solve that complex problem into minor problems that you're now able to put the pieces of the puzzle together to make everybody happy. Now, step 3 of thinking like a programmer is being able to plan before creating your code. There's a high temptation to just start diving in, start changing code, clicking around, typing letters, creating variables, creating objects, creating methods. It's all right there in front of you, and you just want to be able to jump in and start doing it. But I highly recommend sketching out a plan first, whether that's pseudocode or writing on a piece of paper your steps that you're planning on completing, because that reduces your chance of overlooking huge and major outcomes of the application. So what I like to do is when I get a new ticket, I will write down the main objective that we're trying to complete and everything else within the application that might be getting touched. Whether that's part of the database, whether that's an object, because we need to go back through and look at what can change and write tests for those changes. Which brings me to number 4, which is always test and debug your new code, because it is essential to being able to create a solution that has longevity, that's going to be there for the long term. So once you've written code, make sure that you test what you've coded and make sure what you wrote is working in the expected state. Because when bugs arrive, which they will, because we need to be able to think methodically about how we can solve that problem. And step 1 is usually the user saying something doesn't work. Or problem 1 is, hey, we're saying this will work, but it's not. What's wrong? We need to be able to rely on tests to be able to help us identify where the bug really is within our application. Because at the end of the day, we need to be able to understand the problem, isolate the cause, and then implement the solution to be able to have a full-fledged application. Now, to be able to get into those kind of steps though, we need to be able to think logically and systematically. And to be able to do that, we need to cultivate a logical mindset of, if A doesn't work, well then let's try B. If B doesn't work, we then need to try C. It's this cause and effect approach, which is a fundamental and essential part of thinking like a programmer. A logical flow of understanding how things happen can help you anticipate potential challenges and solutions that you may run into in the future. So now let's go into step number 5, which is identifying and seeking patterns. So recognizing reoccurring patterns within the code or just within all of your applications in general, allow you to be able to solve problems quicker. So now there is a quote of senior devs may not be better coders than a mid-level dev, but they have just experienced more problems. So a lot of problems within multiple different projects are going to be very similar in nature. We might be using different objects, we might be using different variables, we might be using different methods, they might be deployed on a different cloud infrastructure, but the problem could remain the same, whether that's a null value, we're trying to extract data from a string that doesn't have any values in it, we're throwing an exception when trying to export files. These are different scenarios that could be very similar in nature among multiple projects. So being able to identify and remembering these patterns can save time and provide quicker solutions for you in the future. And number 6, which is how to think like a programmer, is essential, and it's never stop learning. The tech world is always evolving. Like, it could be a new programming language or a new framework, or AI, generative AI is kind of taking over cloud infrastructure, and you need to be able to regularly update your knowledge. Now, this doesn't necessarily mean that you should go out and learn new programming languages and new frameworks and tools all the time, because that's not necessarily elevating your software engineering ability, but there is some tactics in, learning new algorithms, learning new system and design patterns, being able to write clean code, being able to help mentor others or be mentored yourself. These are essential to being a software engineering and growing within the tech world. So essentially, just remember that thinking like a programmer isn't just about knowing how to code. It's about problem solving. It's about having a mindset that cultivates deep thinking and allows others to be able to grow outside and be able to understand what you're thinking as well. It's essential to have persistence and logical reasoning and relentless curiosity about how things work and how things can be improved. Follow these steps and you'll be thinking like a software engineer in no time.